Okay, 4.2, really just a continuation of 4.1. We've got two more numeration systems to look at. They're grouped here separately because they are quite different than the others that we looked at. So the first one that we're looking at here is the Babylonian numeration system. And the first thing you notice is that they don't have very many symbols, right? 2, in fact, that's it. So their 2 symbols actually are very easy to draw. One of them looks like what you would probably describe as an upside down triangle. And the second one, for the value 10, looks like kind of like an arrowhead, pointing left specifically. When I draw these shorthand, I want you to know what I'm going to draw. I'm going to draw the triangle, not filled in, and I'm going to draw the arrowhead as an arrow, just pointing left. That's just shorthand for me. That is not them, okay? So some features in their system. They do repeat symbols, but only if the value is less than 60. Okay, so if they wanted the number 56, they'd do 5 triangles and 6 arrows. Okay? Once it gets bigger than 60, they use a positional base system. It's base 60. What's our base system? Base 10. Why is it base 10? We have 10 numbers, but why? Fingers. Thank you, Autumn. It's 10 fingers. So if we were like the cartoons that you've seen drawn, have you seen cartoons drawn? How many fingers do they usually draw of cartoon characters?
5.
They usually draw 4.
Oh, 4.
They usually draw 3 fingers and a thumb. That's usually what you see drawn, okay? If that's how God had created you and me, we would most likely be in a base 8 system. So that's kind of crazy, right? The nature of the way God created us has formed the nature of how we do mathematics. So, we have 10 fingers, we have base 10 system. They have a base 60 system. What does that mean? Well, in our system, we have the ones place. Oh, let me use a different color. We have the ones place, and then we have the tens place. We have the hundreds place, but 100 is really just 10 squared. We have the thousands place, but that's really 10 cubed and 10 to the 4th and so on. That's what our system does. Their system has powers of 60. Okay? Now, we're going to need to know what some of those powers of 60 are in a little bit, but not right now. They lacked a 0, and that is going to cause problems. And I've got an example so you can see the kinds of problems that legitimately would cause. It's not going to cause problems on your homework or something. Like, you're not going to see them trying to trick you by this not having something to work right. That's not the point. But I do want you to see that there's flaws, and this is a big flaw in their system. Okay. So, here's our first ones written in their system. So 2 arrows in a triangle, 2 arrows and 2 triangles. And then 4 arrows, 3 triangles, 2 arrows, 1 triangle, 1 arrow, 1 triangle. So, the first thing we need to know is where in the world do we break place value? Because there's lots of symbols here, but clearly there's got to be some reason that they switch between triangles and arrows and triangles and rectangles. Like, what's the switching all about? The switching is about the place value change. Okay? So they would always write the arrows in front of the triangles within one place value. So on this first one, when I go from arrows, 2 arrows, to 1 triangle, and then it goes back to arrows, that tells us the place value changed. Okay, it always goes arrows, triangles, and then I have a place value break if there's going to be one. Now, how many is in front of my yellow line? It's 21, because arrows are worth 10 and triangles are worth 1. That's 21 here. How many is after my yellow line? 22. Okay, everybody good so far? This is not the number 2,122. Okay, it's base 60. So what does it mean? Well, this is the ones place. And this is the not draw it like it's a fraction. This is the 60s place. That's an S. I'll just write 60. So it means that whatever place value it's in, it's multiplied by that. We do this too, right? 300 is 3 times 100. It's in the hundreds place, so we take the 3 and we multiply by 100. Well, the 21 is in the 60s place, so we take the 21 and we multiply it by 60. And you could write, we take the 22 and multiply it by 1, or you can just write that we add 22. Either way is fine. And this is probably the first time where you're going to really need to utilize your calculator in a concentrated way. So grab a calculator. You can use your phone today in class if you want to. You won't be able to, of course, on tests and so forth. But what is 21 times 60 plus 22? Say again, Josh. For the first piece, that's fine. I'll write that down. 1,260, and then I'm adding my 22, so my grand total is 1,282, right? Okay, is that good? Okay, so I want you to try the next one. Put in where you think the place values should switch. Okay, so do the vertical yellow lines like I did as well. If you have pencil, that's probably best, but if you don't, then you can change it later. Did you put where you think they are? Okay, so we have arrows, triangles, and then I need a break because I go back to arrows, triangles, and then there's another break. There's 2 of them this time, right? Okay, what's the number in front of the first vertical breaking point? 43, very good. How about the in-between one? 21. And the one at the end? 11. Yeah. Okay. This is the ones place. This is the 60s place. And this one is the 60 squareds place. So I have 43 times 60 squared plus 21 times 60 plus 11 times 1. All right. Multiply things out, add them up. Do we have a value? That's what I have written down too, Samuel. 156,071. Okay. You ready for something different? Because what I'm about to do is something very different looking than we've done on the other systems. We're going to take our number and put it back in their system. Now, over here, to take their number and to put in our system, we used multiplication, correct? So if we're going to go back the other direction, what do you think we might be using? Division. We are going to use a division algorithm to do this. Algorithm just means process. It's not a scary word, okay? So we're going to use a division algorithm to do this. But I need to know what the powers of 60 are, more like written out, not just written in powers. So like I know the first one's 1 and I know the second one's 60, but I need to know what is 60 squared. It is 3,600. And what is 60 cubed? Do you know? Can you find it? It's 216,000. This system gets really big really quick. And of course it would continue. I'm already kind of big enough to really do what I need to do on this slide, so I'm going to stop. So we want to take the biggest value of this list that will divide the problem we have. So our problem is 3,280. What is the biggest number in my list at the top that will divide that? 60. Right? It's not very big. If I go to 3,600, it's too big. So I'm going to divide this by 60, and it's going to look like good old-fashioned division, almost. This part looks the same as what you would do if you were dividing back in, second, third grade, right? It does. But now I'm going to close it off and put a line on the right. What we want to do is we want to do the division, and you want your calculator to do it. We don't want to do it ourselves. So you're going to take your calculator, and you're going to take 3,280, and you're going to divide by 60. And what I want to know is how many whole number times it goes in. I don't want the decimal part, just the whole number part. 54. And then you're going to take your calculator, and you're going to multiply the 54 times the 60. What's 54 times 60? 240? Is that what's in at the end? Okay, great. And then we subtract. So what do we get when we subtract? 40. And then I divide by 1. We always end with dividing by 1. That will always be our last step. How many times will 1 go into 40? 40 times. 40 times 1 is 40. And the very end will actually give you a 0. It'll always 0 out at the end. Okay, so the answer is over here, but it's not written right yet because I need to write it in Babylonian symbols. So how do I write 54? 5 arrows. There's 5 arrows, 4 triangles. Notice I'm stacking them much like I stacked them with the, who was it? The Egyptians, right? And then how do I get 40? I have 4 arrows. Are we good? Ish? Okay, let's try another one. Always starts out the same question. What's the biggest number in this base system that will divide 3,600? Okay, so the 3,600 will go into 43,205. How many times? 12. What's 12 times 3,600? 43,200, and we're going to subtract. What's that going to give us? 5. I am fully aware that 60 does not go into 5. But because of what I know is coming up next class period, I want you to write the 60 here anyway, and to write down that it goes in 0 times. Okay? We're going to divide by every power of 60 all the way down. We're not going to skip any. Now it's going to go in 0 times, and we're going to get 0 times 60, which is 0. And I'm still going to have a remainder 5 in the next step. Okay? I know that feels like a silly step right now, but it will matter on Thursday. And our last step is to divide by 1. It goes in 5 times. Subtract the 5, get a 0. And I'm almost done. Okay. 12. 0, 5. How do I write the 12?
Arrow, 2 triangles.
Arrow, 2 triangles. Everybody good with that? What do I do with the 0? Nothing. I do not have a 0, and this is a problem. I can skip a little bit of space, and then I can write my 5 next if I wish. But there's no way to know that that space that I skip has a 0 in it. That's a problem, because it's very realistic to look at the answer at the end and to say, that's 12 60s, not 12 3,600s, right? And it's 5 at the end. Likewise, if I had a trailing 0, it would be just as problematic, wouldn't it? How do I know that there's not a 0 at the end and that's in the ones place and everything I have is actually in the 60s and the 60 squares? And I don't know. Probably why we don't use the system. At least one of the reasons. It's got issues, right? Okay, last system. Mayans. Mayans have 3 symbols. Their first symbol looks, they call it a clamshell. It looks kind of like bread to me, like a roll or something, but this is a clamshell. Football, I don't know. The 1 is a dot, and the 5 is a horizontal line.
All extra for the 0.
All extra for the 0. I know. Yeah, the Chinese did too, right? The Chinese went all out for their 0.
They started writing the 0 and they're like, oh, we can't keep doing it.
You can't keep doing that. Make it simpler. Okay, so like the Chinese, it's written vertically. Okay, so that's something that's like, the other section. They write dots on top of lines. They repeat systems within the position on the last one. But the one that's weird is they have a base 20 system. Any idea why they might have base 20 system? It is fingers and toes. Yes, this would have been a society where they would have been barefoot, fingers and toes. You got it. Okay, now here's something that's weird though. It's not just powers of 20, right? That's not what line 3 here says. It go from 1 to 20, not to 20 squared, but to 20 times 18. What's 20 times 18? 360. Any idea why 360 would hold special meaning for the Mayans? It is almost the amount of days in the year, and they're all about the calendar. Do you remember that? The world was going to end in 2012.
I remember.
Yeah? You probably weren't old enough to really remember much of that, but that is where they stopped calendaring, is in 2012. So it was the approximate number of days in the year. That's where that comes from. All right, cool. So we kind of need to know what these powers of 20 are. We'll write them down on our slide in a moment, but let's actually turn their symbols into ours first. Okay, that's the easier of the two ways of doing this. Does anybody need a picture real quick? Okay. Dots on top of lines. So when there are dots on top of lines, it means that if a line goes back into a dot, the place value changed. So the place value must change right here, because dots are on top of lines, and now I see a line on top of dots. What is the value? It's the only place that I know for sure there's a place value change. So what is the value above the yellow line? 4 dots in a line. How much is that? 9. What is the value below the yellow line? 14. 2 lines, 4 dots. Okay, pretty good? But this is values in this modified base 20. So this is the ones place and this is the 20s place. So it's like you have 9 $20 bills and 14 ones. Can you picture that? Yeah. So this is 9 times 20 plus 14 times 1. And if we add those together, we have 194. Are we good? Okay. The next one has a shell in it, right? The shell holds place values, so there's definitely place value changes both above and below the shell. Are there any other place value changes? Yeah, where? Where is there one more? There's one more place value change. After the line right here, yeah, before that dot. So those are my place value changes, right? Because dots go on top of lines. And in that location, it went from line, dot, line. Okay, so my place value changed in between. What value do I have above the top line? 17. I have 3 5s and 2 1s. That's 17. The shell is 0. The line is 5. It's the 20s place, but it's 5, right? It means 5. And how about below the yellow line?
6.
Down 6. Okay, so this is the ones place. Hang on, I need to move this over a little bit. This is the 20s place. This one is the 20 times 18s place. And this one would be 20 squared times 18. And the powers of 20 do go up. They keep going up on the 20. 20 squared, 20 cubed, so forth, but always times 18 above this. So we're going to take 17 times 20 squared times 18 plus, the next one's 0, so I'm just going to write it as 0, plus 5 times 20 plus 6 times 1. And again, if we multiply and add them together, we have 122,506. Okay, one more slide. Ready? Going back into their system, right? It's going to look just like the division algorithm that we did for the Babylonians, all right? But we need to know what the powers are in their base system. So they have the ones place and they have the 20s place. The next one's 20 times 18, which we already said was 360, so that's cool. Now I need 20 times 18 times another 20. What's next? Mm-hmm. 7,200. We'll do one more. What's after 7,200 times another 20?
144,000.
Yep, 144,000. And it will continue. But this is probably enough for our discussion. What is the biggest number that divides 208? Yeah, it's just the 20, right? How many 20s are there in 208, right? Dividing. 10. And 10 times 20 is 200. So we subtract to get 8. How many 1s are there in 8? 8. Subtract my 8. I have a 0 at the end and I'm done. But now I need to write these symbols. The answer is not 108. Right? It has to be written in their symbols. How do I write 10 in their system? 2 lines. And how do I write an 8 in their system?
Dot, line.
3 dots and a line. Okay, does that make sense? All right, the next one's the most interesting. Well, we've seen other interesting ones today too. What's the biggest number that will divide 58,532? 7,200. How many times will 7,200 go into 58,532? 8. Okay, what is 8 times 7,200?
57,600.
Okay. And if I subtract, what do I get?
932.
Yep, you're right, Josh. 932. Thank you. Anybody could help him out too, you know. Just saying. You're just going to let him do all this. Okay. 7,200. What would we divide by next? 360. 360 first. Go straight down the list. How many 360s are there in 932? There are 2. That multiplies to 720. So what is 932 minus 720? 212. What will I divide by next? 20. How many 20s are there in 212? 10. 10 times 20 is?
200.
Subtract gives me 12. That's right. And then we divide by our 1 to give us our 12 at the end, right? Okay. Let's write these symbols. So I have 8, 2, 10, 12. You might be thinking, well, what interesting thing is about to happen? You just wait. Okay, how do I write an 8? Dot, 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 line. How do I write a 2? How do I write a 10? How do I write a 12? Okay, this is correct. We didn't do anything wrong. But what's the problem? The 2 over the 10. You're exactly right. This 2 over the 10 here, why in the world would I know that that's 2 in one place value and 10 in the next? There's nothing. I have no way of knowing, right? So while I may have a 0, and that helped over here, right? I had a 0 placeholder. That's definitely a step up. I still have a problem. I have a problem that this is indistinguishable from the number that should be 8, 12, 12, right? Which is a much smaller number than 58,532. And that's it for today.